Hi, Sportster Paul here. We're checking out VisualMill, a CAM tool, computer-aided manufacturing, makes G-code to run your milling machine. This is a third impression. I did figure out things I was doing wrong in the second and the first one, and at the end of this, we'll show you how I fixed pockets not having arcs in the corner. That's an advanced cutting parameter. I had to make a kludge sketch in order to get that flat so that it would go down in levels, do it like a pocket and use a sketch instead of the actual flat surface. Haven't figured out the right way to do that, if there is one. Then the angles I changed from horizontal finishing to parallel finishing, turned them sideways, stretched them out, and fixed that little thing. So let's just start on the other side, the second setup. And there's some things I'd like to talk about. Maybe you folks could help me. So here's SolidWorks, okay, and I thought we'd show you how to get into this add-ins. I turned it off. When you install VisualMill, it takes over. It does run it at startup, run it now, and I don't like that. I'd rather just do this. Then it says free mill. I tried that. I don't even know if I'll make a video. It's not fair to them. This program is much better than that free mill, which is pretty much an advertisement. It's not a usable CAM package. You're going to run the CAM demo. I'm doing milling. Premium is, I think, a $10,000, way beyond what I need or want. Professional is full 3D. I think that's about $5,000 if I remember. They have pricing. You know, unlike a lot of these CAM vendors, you can actually see what it would cost. You can't save anything, so we got to start from scratch every time. Here's this test part my buddy made. CAM data. I think this is left over because I use this part, or he actually used it for SolidWorks CAM made by CamWorks. So I say no now, just so it doesn't get confused. I've already saved it with the stock. We got that much you can save. I did want to mention, you know, if you do this, it makes your life tough. As much as I hate having a real wide thing, when this dialogue or whatever you call it, this panel is wide enough, you get more planar pick stuff easier. Okay, so let's go. Oh, see the tool. This is another thing I didn't understand because there was something about regions and I'm studying regions. And what about regions? Well, the machining browser object, blah, blah, blah. And where is it? How do I get there? This thing is a little button right here. Off, on, machining objects. And you can do tools. And here's where you do regions. It has automatic feature recognition. I tried it. It doesn't work. It doesn't recognize anything. We'll maybe go over that at the end as well. So, and where I noticed this thing was when I had some tool paths and I double click on a tool path, it would fill up the whole thing. And it's like, okay, how do I get out of it? How do I leave this? And I didn't realize it's a pop-up panel that, you know, you can just slide down. If you leave it here with tool paths, it shows you the tool times. So that was fun. Setup, okay, it defaults to, I remembered I had a setup 1. Work 0. It's smart. It's not like CamWorks or SolidWorks CAM that would open dialog. If I close the dialog box on this screen that you're seeing, it would poof out of existence, and I'd have to go hunt it down using screen resolution and move monitors around virtually till I found the dialog box. This one is smart enough to say, he's got 4 screens. Let's just open on an empty screen and leave this uncluttered. So that's why I'm pulling and pushing them here. Say sets to stock box. This is just the way I figured to do it. Find this corner with an edge finder and a Z, or I've got a little tool probe, and that'll do this corner. So we'll say generate. Great. There's part 0. I'd already set up using machine setup all of this business to get the directions right. So Y, positive Y goes to the back, like in my particular Avid Benchtop Pro. Love this little machine. So, and then the other thing, it homes all the way forward and to the left. So this red arrow is X, so positive X is to the right. I would have this thing in a vise like this, fixed jaw, the vise in the back, movable jaw in the front. And you always use the part 0, you always do it off of the fixed jaw because of variations in stock size isn't moving stuff around. So that's that. Now, since we did all these other ones in part 2, you know, we got to the top stuff. And because this thing crashed when I did all of them ahead of time and then just tried to add this second setup, I thought we'll do the second setup right now. So here, new setup. It gives you the same thing. Now it wants to know about the machine stuff. So I figure to put it in the vise, flipped over to do the bottom and to do these 5 holes, face it, would be like this. And I've learned, since Z is going in the right direction, Z is off to the right, just like in my mill, I said around the x-axis, go once, twice. And it doesn't take the old one away, which is very confusing. And you say generate, and so now that machine is correct again. Z is up, Y is towards the back, X is to the right. So this is how it would sit. Now, the problem I've had, I started thinking, I thought I'd want to make work 0 here. Oh, set it to the stock box. But you can't. That's not valid. If you locate to the stock, variations in stock thickness would make the part a different height. So what I want to do is find this corner, because I figure I could find the top of the parallels when I put this thing back in the, remember, all this stock in the bottom is going to be gone. That's all machined off in setup 1. So I'm holding it in the vise on the part itself right here, and I figure I could find this corner on the parallel and with a tool or with a part stop and get all that figured out. I can't do it. If I say set the stock box there, say set the part box, it's decided, well, it's going to add a bunch of meat to the part that doesn't really belong. So I'm not sure what I'm doing. I'm probably doing something wrong. It's not the program. I figured, since I did figure, you see there's stock up here. This is the point that's uncluttered. Southwest, oh no, lowest Z, northwest. So that's kind of where I want it, except I want it there. And I thought these, you say pick, well, can I pick something? No, that doesn't work. This is just goofy, what it does. You know, you think it would move stuff properly, but it doesn't. Oh, now it's working. Every time I use this program, it operates different. Well, that's almost, let's see if I can zero this out. 0, enter. How about that? When I tried this rehearsing 3 times this morning, no, couldn't get that to work. Hey, success. So now, hopefully, by referring part 0 to the part itself, now we're sure it's going to be actually an inch tall like it's supposed to be. Whereas if you do it by the stock, you're counting on the stock size and going down from the top. So I think this is the right way. Machinists can correct me. You guys are a lot smarter. I'm an engineer just learning machining. I'll ask my buddy about this. So what you want to do, you want to face it, right? It's got the stock. It's got all this stock on the top that we left a lot of meat here to hold it in the vise. But now we flipped it over. All this stuff is machined off in the top of the part. So we're doing the bottom. So we're here, and we're going to do 2-axis facing. Got to drag it on for you folks. It doesn't have a tool yet. It would if, you know, we were doing from the top. You add a tool. And I've learned you go here, put 2/10. That automatically changes that. The flutes, if we get around to doing the top and showing you the things I changed there, we'll need it at least 1.3 long so it doesn't crash when it does the perimeter of the part. Shoulder length, I just minimize that. Say OK. So now it's got a tool. Oh, I left it a ball mill. They default to ball mill. Can I change it to an end mill? No, I guess not. Create tool. This is why I think it's meant to compete with Vectric and carve eagles on wooden signs and not machining, because they default to a ball mill. Why would you ever do that? All right, back to drain in the swamp. 2.5 flute length. We're going to need that ball mill anyway if we can get around to it. Tool length, nice and stubby, so it's stiff. And shoulder length, I minimize that. Oh, feeds and speeds. I want 12,000 because I learned going 16,000 screws things up. Look at the numbers. 30 and 30. You know, this is obviously a programmer who looks at his calculator and writes down all 15 digits. It's like, no, there's significant digits. You know, there's some meaningful numbers here. I had a professor who would flunk you if you wrote like 7 decimal places. You know, how many? What good is the data? If it's good to 3, then you need 3 decimal places. All right, so I think this is it. Save as a new tool. Okay, now we got flat mill. So that's what we want to do. Control geometry, I've learned, this is when you learn to love the program. Don't pick anything. think, oh, I should pick this face or I should pick, no, don't pick anything. It's smart. And then include stock model silhouette because you don't want it to leave little posts or little things in the corners that fall off. Do that, say generate, bang, there you go. Beautiful, huh? You can do a quick simulation to end, compare. See, it's all green. That means it's true. Which is within 3/10,000ths of an inch, both ways. Excellent. So we're happy about that. And you can see the stock is gone. Now, if we were doing this in the right order, right, if setup 1 was already done, all this stock in the bottom would be gone too. We'd just be finishing up. But just in case the program might crash, I've been renaming stuff as I'm going too, except nothing works. I can't get anything to work. Facing. So then light that up and say 2x, no, holes. There's nothing calling out center drill. See, these are some of the little weird things here. So I know I need a tool, edit, create a tool. They give you a choice right here, center drill. It looks proper, but whatever programmer did this must not have learned that these angles are part of a center drill. I mean, I think every center drill I know that you bury it down into this flank here, and that's what makes a ramp to locate the next drill coming. Well, let's make the tip diameter 125, the shoulder diameter 1/4 of an inch. Tip angle, I had to look on the SolidWorks drawing. It's 118. Or no. That's the regular drill. We can leave this 120. Tool length, that's absurd, right? Shoulder length. Let's do that. Make the tool nice and stubby. Because if that holder is going to hit anything. Flute length. Okay, it's nice they give you this drawing, right? There's a lot of thought that has gone into this. Flute length. I guess that's okay. We'll leave it that long. Say okay. We'll pick the center drill. Hole features, cut parameters. I know for a fact I want 125 after playing and seeing it going too deep and approach distance 1/10 of an inch. I think it's smart enough now. Set control geometry, of course. I forgot that. Generate. Okay, save. All right. But there is no place to do hole geometry here, is there? Hole features. Cut parameters. Okay, they rename things. Select holes on a flat area. Bang, bang. This is nice, right? Generate. Boom. And if I did things right, when we simulate to end, see, they don't go all the way through. Because for a while, it was plunging. What point is having it if you're going to do it that deep? Now, once again, I wish they'd have a few more center drill, zinc. One of the things I've seen them do, I think, and you can do a control copy, control here. And now you can make this one. Windows and their renaming conventions. Drill. Because we already selected where it's going to go. And so here you do, it's got the locations correct. Now it's just cut parameters. The drill depth, I can tell you from a lot of playing around, even though Dave defined the holes, SolidWorks defines the holes, 0.38, 0.44 is what ends up matching the way the model shows the holes. Cut parameters, 0.44, generate. I guess it's going to do its thing. Can't be center drill 1. I'm not doing this with the right procedure. Select a tool. Now we want a conventional drill. Its flute length is 2 inches. Tool diameter 0.201, which happens to be the tap drill for a 1/4-20. Is that? I guess so. Shoulder length, I don't know. Flute length, that's not too important. Tool length. Once again, you really should model all this accurately if you don't want your tool holder clanking into a clamp or some other problem. But this is just the principles. I've got the diameter right. Okay. Drill. Generate. Let's look again at those parameters. 0.44. I can generate it again, doesn't matter. And then, you know, if you do simulate to end, things kind of look the way they're supposed to. You can compare, you know, the fact that it's just touching green down there, well, yeah, that's all that work I did to try to see how the blind holes. Oh, maybe I can improve this. You're going to love this. Drill 1. That's because I looked on Dave's, Dave Rui made this part. Drill 1, double click it. Double click it. No, edit it. He used 118 tip. I don't know if that's common or something SolidWorks chose. Save edits to tool. Editing existing tool, yes. Generate, just in case. Simulate, to end, compare. See, they're all green. And that was tediously, maybe, well, 3.8 doesn't work. It's deeper. Maybe 4. No, not quite. 0.44. That's where it got so that the material that this drill thinks it removes. This is a serious problem, right? Who defines how, is it the shank? Is it the corner of the flute? Is it the tip of the drill? Everybody does it their own programmer herding cats ways. So that's that. Then rather than copy paste because the locations are the same, this one, because it's a tap, you do tapping. And you get this dialog box. And let's see, tool. You got to create a tool. It comes with a tap. This is actually a 20 thread, quarter 20 is a thread pitch of 0.05. So that's right. Tool diameter of 1/2 inch. That's not right. I mean, why aren't these canned? Is it because it's a demo program? I'd expect like 40 different taps standard in here. Shank diameter, quarter, tool length, stubby it up. Flute length, stubby it up. See how goofy they are? They define tool length not as the length of the tool, but as a protrusion of the tool out of your collet. I think all this is right. Say, okay. Hole features, no. Oh, yeah, we got to add the hole features, don't we? Flat area, bang, good. See, I'm getting familiar with this. Clearance plane cut parameters, here it is. 0.5, that would crash and break a tap, not a good thing. I can't do rigid tapping in this Avid Benchtop Pro, right? That's not going to work. But I could center drill and then hand tap. So I wouldn't have this operation for my machine. But I figure you'd be curious. Let's go down 0.4 because we went 44 on the drill. And that still might get us into trouble. Like, is it the tip of the drill? The corners of the drill? I don't know. Say generate. Kind of looks right. It's going blind there. You know, looks probably going too far there. But it's the principle, not the suffering, to end. What's going on? We're wrong side, aren't we? And then this is another problem I had that, well, it shows stock here. It's not made this any color. This blue is because we haven't machined the whole top side of this. The green said it's right, but why is this annular ring? You can see that the quarter-inch tap, it matches the dashed holes that SolidWorks uses to represent a tapped hole. They put dashed lines, a dashed circle around the physical tap drill size hole. I don't know. So that's that. So not bad. 18 minutes in, we're really jamming. Frank Zappa would say, let's go to setup 1. Work 0. We're going to do the same tricks now. See, now we've got it's in the vise like this. Let's go simulate so you can see the part. Huh? That would help, wouldn't it? Here, not too bad, right? Life is good. Say 2-axis, facing. Make sure we got the right tool, flat mill, control geometry. Pick this, but don't pick anything. It's very smart. Generate, look at that. Sweet. So that's good. Now, to show you the dynamics, facing, made a mistake here, facing, parameters, bring your parameters over, cut levels, I happen to know it's 4/10 of an inch. we've learned never leave this pegged here or here because it causes my particular installation with Windows 7 where it didn't install right because I had a newer version of a Visual C++ library they had to install 2 of. Can't complete, failed, because newer version already exists. Is that why this thing's crashing? I don't know. Let's go 0.12, 0.12, generate. Now it's confused for where they are. Come on, double click. We know what we're doing. Cut levels. The geometry, I think you say, is at the bottom now. Generate. That's what we want to see. Because it was at 4/10 of an inch. I don't want to, in this gantry style, router style mill, I don't want to be whacking off 4/10 of an inch of aluminum, right? I want to take it in thin cuts. And I got this thing about going fast, and I saw how inaccurate things got from all the stress and strain and loading. So we fixed that. Let's go back to 1. Setup 1. Work 0. 2-axis facing. We're done. Now I'll show you some of those tricks. We might get, we'll see. We'll see. The pocket, okay? 2-axis pocketing. For this thing, you say, select curves and edges. I did find out you can say tangency here. You can go here. Oh, I got a filter accidentally clicked on. All right. I can say here, select tangency there. Get you a little bit closer. Here, here. How about this little one? There. And then you can go here and here. So now we've got the definition of the pocket. You say, okay, tool, flat mill, cut parameters. I found out, even though I said I couldn't make it finer than 1/1000th, you can make it 1/10 if you don't mess right away and try to make this a 0. That's why it was crashing. The combination of 1/10 and some small number here. Cut levels. This is what I love so much about this thing, that you can go, see it says select the start point for the cut. So that's a point there. Now it says select end point. Go there. And it knows it's 625. And not only does it default to doing all roughing, but if we leave it here 0, it's going to plunge 3 feet down into the part. I mean, I just know. I've been there. So we'll save everybody some time and trouble. Let's do, this would be nice, right? And once again, the rough and finish, does that change feeds and speeds? I looked around. I couldn't find it. So this you can actually leave without corrupting. Here, oh, the corners. Well, let's do it. Let's do it. Let's add 0, 1, just so it generates. There they are, right? And you notice this is a straight, they didn't put an arc in here. Even though my buddy Dave, who made this part of Befuddle Cam programs, he didn't make this diameter of 0.25, same as the tool, because that means the tool has to go to the mathematical center, stop, and then do another G code to keep going. This one, you can just do a little arc because it's 0.26, that little bit extra. And that's what they've approximated with this straight line segment. And that's why if we say simulate, to end, compare, you get all this blue, over 1/1000th. I think it was almost 5/1000ths when we did it. But of course, we also have 1/1000th of, wait a minute. Let's do a little housekeeping. I never can get it right. Unsaved document, no kidding. I wish I could save it. And then this is the deep pocket. Okay, so let's double click parameters. Now watch this. This is a fix from last advanced cut parameters. Run this out to 1/10. Say generate. See our blue now, dark blue? That's because it's an arc. And if you want to get even closer, hit parameters again, drag it over. You must be getting dizzy watching me drag it. Now, if you go to 0 too soon, it gets confused. But now we should be able to take this out and make the stock allowance a 0. I found out why they consider pocketing to be a roughing operation. So let's always leave some stock allowance. Profiling, that's for a finish cut. I'll show you how I figured why, and that's probably common machining. That's on me for not knowing. Generate. See how it, toolpath all popped out a little? Simulate, to end. Oops, I don't know what I'm doing. No more blue, huh? Now the interesting thing is, when I did this part practice run earlier today, I did the bottom, then I did the top, and unlike here, there was some blue stripes in it. So this program never seems to act the same twice, but that's on me. Okay, let's keep going. Right, this is exciting. So now we'll do another 2-axis, another pocket. Now we got to do our kludge, right? And this is where we go, kludge sketch for cam. This was so, because it can't follow this curve, it would leave all kinds of meat, the breakout holes, that Dave knew what he was doing, why this fool's cam. Same thing here, it would leave meat that it's not supposed to. In SolidWorks cam, it actually put a little gouge up here. So the kludge sketch for cam that I drew in the part model and then hid the sketch. Okay, great. Tool, make sure, yeah, it's the flat mill, clearance plane, cut parameters. Once again, let's make this a 10,000th. Let's add a 0 there just for grins. Step over distance, that's all fine. Cut levels. Now the geometry, the thing we pick to define this, is at the bottom. So you do that. You do our little pick thing. One of the things I adore about this program, because you can say, here, I'm a very visual learning kind of guy. 1.25, never leave this over on a 0 for me, just me, with my goofy Windows 7. And we'll just let it do 2 whacks. Say generate, there they are. 2 setups. Now you'll notice straight line segments in the corner because parameters, double click, drag it so you guys can see it. Advanced cut parameters. Add a couple zeros there. Cut parameters. Change this to a 0 and hope it doesn't crash. Generate. So now you can see their little blue arcs there. Right? They're not straight line segments. And as you would expect, what that means is when you do a simulation to end compare, oh, is this thing sluggish? It doesn't like where it's at, I can tell you that much. Here we go. Let's do it this way. Come in there. It's speedy here. It's the compare thing, I think. See, there's no discontinuity from that last 1/8 of an inch or whatever, 0.625, I can't remember. 125 that it took off. So the sets are identical. And then let's back out. See the top surface of that little plateau. Yeah, the blue here, that's to be expected. We haven't drilled them. When we go simulate at the very end, that second setup, life is good. So we faced it. We did a deep pocket. We did a shallow. Enter shallow pocket, deep pocket. Oh, I wanted to do the perimeter. 2-axis here. For that, I tried selecting the bottom. I want to go a little below the bottom, and if you pick just the 4 lines that define the corner, you can't do that. So, once again, select curve edges. Here, 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 here. I don't think it lets me do the tangent. See, if you say loop, it always picks the wrong thing. So we got the perimeter defined. The tool is the flat mill. Cut levels, total depth cut. I just happen to know it's 1.02. The part's 1 inch thick, and I want to go 20 below it. So when we face off the bottom side, it doesn't leave a razor sharp edge, so it overcuts a little, 20 thousandths. Same thing, don't leave these 0. Life gets really rough. We don't want to take a big whack. We want to take like 1/8 inch. Let's do 1/10 of an inch. Advanced cut. I don't think none of this matters now. Control, no. Cut parameters. Here they are. It's like they put the tabs in different dialogues for different operations have the same thing in different locations. All right, maybe if you got in a conference room. Climb. I should make everything climb. I had a nice Zoom conversation with my machinist rockstar buddy Dave, who designed this part to fool up cams things. Total cut width, I've learned, lots of practice. 0.125, and step cut, I think generate there. So that's enough to get the corners, even though it's cutting a little bit of air out here. This is enough to get the corners. Otherwise, it leaves little tiny posts from on the stock, right? Because the stock is that big. This is just enough. Let's rename this to perimeter. Thank. And have we? Okay, because this is a perimeter or a profiling or whatever they called it, it doesn't leave that stock allowance. So that's good. Tolerance, let's tighten that up. 1/10 is good. I don't think advanced cut parameters, that's just for arcs. So you don't really need that. So let's say generate, did its thing. And this is the same, it never acts the same twice. Simulate to end. Compare. This used to be green, so I'm not sure. It only did that operation, right? If you highlight setup 1 and say to end, now it's showing what we want. I interrupted it. It finished now. Okay, so that's kind of what we expected. I'm going to go a little long because I think you'd be curious what I did wrong. Maybe not wrong, but ways I found to fix. Did how to simulate. We're in the program. We did the perimeter, the shallow pocket. Now let's do this flat. Once again, I tried to do 3-axis clear flats. It won't do it in levels. It won't take thin cuts. There's no way to set. Oh no, I want to come down on this. I don't want to just whack off, you know, 1/2 inch of material. So I said, now let's fool it. Make it a pocket. Select this, which lets you, oh look, see it did all of this. Clear selections. Kludge sketch for cam flats. That's this. This is how I fooled it so that if you just say define this face as the pocket, then it goes up to the edge, these little corners, because it can't do the corners. Tool, flat mill, cut parameters, always leave in stock. We know this. 0. Actually, it's not too critical here because this stock allowance is on the side. So the Z will be correct. So we probably just say generate. There it is. Although, yeah, the whole point of this was to get a bunch of levels, and I didn't do that. This is the flat. And open it up, parameters, drag it over, cut levels. The control geometry is at the bottom. We want, come on, light up a point for crying out loud. There. And then another point down here. There. 32625. Okay, put this in the middle so the program doesn't crash. Let it go in tenths. Might as well make them the same. Say generate. So that's how I got it to take less of a whack, just kind of take little cuts, less depth, you know, do multiple. Kludgy, that's why I call it a kludge sketch. You know, I had to actually draw a sketch, which I used to think, well, standalone package, you know, what's wrong with that? Now I'm thinking if I got to draw all this stuff to get this cam to work the way I want, and I had to do it in SolidWorks cam, I assume I'll have to do it in most of them. Maybe I do want something that works inside SolidWorks. So that was the flat. Now watch how I fix this next thing. 3-axis. I did horizontal finishing. It left material right here because I couldn't fix that. The secret was to go to parallel finishing. It keeps. Okay. I want select flat areas. I want this and this. Say OK. Then select regions and kludge sketch for cam angles. That's these little that I had to draw in SolidWorks, you know, in the part model. So now it's got all those areas. And, oh, tool, we want to say that ball mill. Generate. Cool, right? Now it's getting close. And everything here is clickety, clickety, click to get a little closer. As long as you can converge, right? It's when it blows up that I get frustrated. So we know what to kind of do now. We hit parameters, double click it. And angle of cuts. right? Just a little bit of reading, patience. Well, what happens if we change them 90? Generate. Oh, baby. Getting closer and closer, right? Okay, we want to make it finer. We don't want to leave big scallops. Step over control, tool diameter. Let's make it like we did 0.01. Generate. Boom. And because we added those little sketches, see before, it does the math where it uses this line, goes straight up, and it won't let the tool, the center of that tool, go any further. So it leaves a big scallop here. By adding this little patch, and you could see it could be narrower, right? It could be that. It runs the tool path all the way down till the theoretical end of the ball mill touches and makes this corner scallop much smaller. So let's see if we can show you the problem. Compare. Oh, I can't compare if you don't run it. See all this material right here? That's the issue. Let's do setup 1 to end. It's thinking, it's doing the perimeter, it's doing the pocket, it's doing flat, doing a parallel finishing. Compare. See? Now with SolidWorks CAM, the way, and this is because Dave's a genius, and he knew that putting this angle on this area, that pulls up. SolidWorks CAM, same as CamWorks, they let you define the radius. They do all this Z. They want to come down and, like a bathtub and do it like that. These guys are much more efficient. They get down, they stay down, life is good. Here, and this is why I changed it to, what was it? Horizontal finishing or parallel finishing? Yeah, I changed it to parallel. Let's go look. Remind everybody. I had it horizontal, now we're doing parallel finishing. And watch this trick. Parameters. Entry, exit. The connections, meaning, when it's got to go to the next level. This is a connection. This is a connection. You can make them circles, you can make them squares. I didn't care about that. What I love is when I go linear, the angle, well, no, that's a whole problem. It's pulling up. Set the angle to 0. Life is good. And then make this pretty big. Make it, half of the ball end wide. Make it the radius of the tool. Now say generate. Look at that, baby. See, it extends them out. And I can tell you we're going to want to turn off the toolpath visibility, come up to the setup, simulate the whole mess. That perimeter's taking a while. Maybe I set too many 10,000ths there. Parallel finishing, compare. See, so that whole meat that was left here, gone. And maybe you want to do this one separate, We're going to be 40 minutes before I'm done. I'm sorry, but I wanted to get this all dialed to show you folks. Last thing to do, I guess, is set up 2, or maybe you do a machining job and simulate the whole job. Nothing to simulate. Set up 2. Will it do? Yeah. So there's our part. Got the through holes. You do the compares. Why is it leaving the gray? I mean, that should be a color, right? It should be blue or red. Maybe because it's a tap. They say, well, it would mislead you. That's pretty sophisticated because it showed up red in SolidWorks CAM because the tap is defined by the outside diameter. The hole that SolidWorks uses for the model is decided by the tap drill, the smaller inside root diameter of the tap. But this is all pretty good. I wish I could figure out, this time it kept the more accurate corners. And it hasn't crashed. Miraculous. So there it is. Sorry to make this so long. There's a bunch of other stuff I wanted to talk about. Let me look here. Pockets, clear to flats, show the feature recognition. Oh, the feature recognition. Here. That's this thing, right? Off, on, machining objects. Automatic feature detection. You hit it, it thinks. Sorry, can't find anything. Interactive feature detection. There, I went here and said, okay, give it some help. And it comes up with a bunch of features. It tries to do the holes from the top. And then here is where you can machine what you recognized. So they're trying to compete with CamWorks, with all about automatic feature recognition. I don't see them bragging about it because obviously it's not ready for prime time. But this is what taught me, one interesting thing, if you tell it to do the stuff, that's when I saw some tools appear. Matter of fact, when it did automatic feature recognition, it tried to use a countersink tool a 45-degree countersink to do these big flats, which I guess is one way to do it. So that's that. Let's get going. All right, hope you enjoyed it. This is the tool. I might think some more about what would be good to know about CamWorks, but I'm almost ready to move on. It's got interesting. I can't use it because of the bugs in my particular installation. I'm sure most people don't have these dialog boxes changing from zeros to one. And then the fact that the G-Code simulator program only works under maintenance. That's kind of a sour taste in my mouth for that. So there's other packages out there. There's Bobcat. We're going to look at them. We're going to look at, get pricing on others. If it's 8-10 grand, I read SprutCam might be 8 grand. That's a little out of my price range. I want something, 4 or 5, somewhere like that, full 3D. So that's where we are. Hope you folks are doing good. May your cam packages work out. Catch you next time.